the background information section of the activity that's called Sudden Stops Hurt. That's the one that I just handed out to everybody. It looks like that.
Wait, so what do you mean when you say background?
Okay, good question.
Right here, it says background information.
So we're going to start this together today after the presentations. Basically, it's that I'm going to have you start to think about a car crash. But when you're thinking about it and kind of writing the story of the car crash, I'm going to have you include some ideas from Newton's laws to help you explain like why the cars behave the way that they do during a car crash.
Yeah, so
I put lines on the front and on the back of this page to give you like a big space to write out your whole story about the car crash, including some of these 4 ideas. But we'll go over it together at the end of class before you guys leave. We're going to hear 2 presentations today, one about the Newton's second law and one about Newton's third law, so that you can add ideas into your If Newton Was in Rain or Scholars explanations. Thank you. Okay, so I need everybody's attention up here. I'm getting ready to explain too, so thanks. So you're going to be listening for main ideas, which might come when they talk about the concept, or it might come when they talk about the headline. Okay. You're going to be listening for an example, so like what kind of movement out in the real world is exhibited, with this law. And then you're going to be listening for any vocabulary or maybe some mathematical ideas or relationships. And then you're also going to be listening for how this law might help explain a part of Mr. Little on rollerblades, Miss Stein on rollerblades. There's a picture? Okay, good. All right, and remember you guys are going to try not to block your audience. Okay. So at the top of your chart, you should have Newton's second law of motion. I'm going to hold the poster while they explain. And then you can ask questions at the end. Okay. All right, so who's beginning?
I'm already short. Okay, so we're gonna be doing the second law. The thing. The motion cop is our headline. Yeah.
Okay.
And then our concept. Our concept for the day for Newton's second law is that the acceleration of an object is the concept is this section was about Newton's second law of motion. Basically, this law, acceleration, net force over mass. You need force to accelerate, but mass matters to how much force you need to accelerate. So in summarized form, if you have force, it's going to help you accelerate, but if you have a lot of massive, it's going to decrease acceleration. The whole of Newton's second law is the acceleration of an object is directly proportional to the net force acting on the object is in the direction of the net force and is inversely proportional to the mass of the object.
Okay, that was a lot of big words.
Yeah, can you bury it?
Yeah. Okay,
can you say it in regular people?
Well, that's kind of like why in the concept we said basically his law is acceleration equals net force over mass, and so basically your acceleration is based on how much force you put into it, and if you have a bigger mass, then it takes more force to accelerate forward. So it's really just talking about how much force it will take to do more acceleration. So if you have less force, there's going to be less acceleration. And if you have more massive force, you're going to have less acceleration. It's going to lose its acceleration.
For example, we use...
Time out for just a second, because I feel like Helena just said a whole lot of information and people need to catch up.
Catch up. I don't like catch up.
Juan.
Oh, man.
Bless you, my goodness.
That was like a hurricane. Okay. That's why I'm trying to yell at us. Why you want me like float back? Deceleration.
The force of your sneeze is gonna make you accelerate backwards.
Nerds.
No, you said that. Okay, he pushed me and I was like, my force is gonna make that mass accelerate.
Okay. Next. Which part is next?
Okay, so our example. So, for our example, we're using, one of our examples is, we are like using the fat person with a back, with a, what's it called? Parachute. And skinny person with a parachute, right? Okay, and then like, the fat person has more mass in weight, right? So, like, it takes more, it like takes, like, the air, the green air, you know, normal air going up, is like going inside the parachute and like it like takes longer to fill up and then like come, like it goes like in a cycle, right? So like it's like, yeah.
So I'm hearing this brilliant explanation of parachuting, but then I'm also hearing Hanad having conversations, which is not only bad for your learning, but disrespectful to Jael's really brilliant explanation of parachutes.
And to the other people who tried to help me.
Yeah,
Okay?
yeah.
So please continue with the fat guy parachuting.
Okay, so the fat guy's parachute, it takes, it takes like more air to fill up the parachute and like come out, so it comes out, the air comes out faster. And then for the skinny person, it has less mass, so it's like the same thing for the fat person, but just like it takes less air. No, wait. Is that? Yeah. Okay, so it takes less air for like less air to come out and then like come out of the parachute and fill up.
No offense to skinny or fat.
Yeah.
We're just trying to math compare and then the only people.
And
By the way, that's a girl.
That's a girl. Okay, that's a girl, not a boy.
and the more mass, it since like I drew the
Just please listen. I know it's funny to look at their drawing, but pay attention, please. And don't block your audience.
There's no
Go ahead.
So I drew the fat person like more like below the skinny person because it has more mass and more mass accelerates more. Good job.
Okay. Vocabulary. Oh yeah, the vocabulary is terminal speed. Is when it reached the terminal speed when the acceleration terminates. Mechanical thing.
Equilibrium.
Yeah, that.
Say it again.
Equilibrium. Is this is when the acceleration of an object is zero, and the terminal velocity if there is a concern with direction, the all-falling objects, we say it has reached its terminal velocity. Okay, so next we're going to go to math, and math is really important to science right now. So, really, math equations is important to science. Do you guys need to catch up on the vocab? Yes. Yeah.
I would say that out of those vocabulary words, the one that you should probably pay attention to is the equilibrium idea.
Yeah.
The two terminal ideas are interesting, but not main ideas right now. The equilibrium one is a main idea.
That's why it's about that.
Yeah. Okay, I think you can start explaining some of the math ideas.
Math is very important right now. Alright, so force equals mass times acceleration. And force divided by mass equals acceleration. And then mass equals force divided by acceleration. So we're just saying that force divided by acceleration will get you to mass. And if you have mass times acceleration, you're going to get a force. And force divided by mass, you can just copy that.
Okay, now like some other ideas. Okay, so other ideas that we have is that support force is another term. Support force is also called the normal force, and that the heavier you are, would basically like summing up Yael's picture is that the heavier you are, then the faster you'll fall in air.
So, okay. So, in this one, if you pull from one side 40 Newtons, and then you pull on the opposite side 40 also, the force is gonna be 0, and it's like not gonna move, well, the thing is gonna be 0, and it's not gonna move because
That's an example of mechanical equilibrium.
yeah, it's not gonna move. The acceleration is at 0 because it's not gonna move because it has the same amount of force pulling it on both sides. Yeah.
And then the other one was just like a simple example of that force causes things to accelerate.
And that all wound up to like skating. If like you have more force on one leg than the other, you're gonna be gliding on like what Yael used to say. He said like with a gliding foot. So like if you put more force on one foot, you're gonna be able to accelerate way more.
And it's like you're like the more mass you have, then the more force like you need to push yourself. Because like if you're really light, then it's gonna be easy. You don't need to use as much force to accelerate. But if you're bigger, then you have to use more force, and the force that you need to give yourself is determined on how like your mass.
And like if you like put your weight down and then you start moving your legs and feet, you'll be able to start like faster because like the force is going down on the ground, and the mass is gonna like build up to acceleration. It's gonna like make you go better, like faster.
So basically all that runs up to that in order for you to in order for you to accelerate, you need force, and the amount of force needed depends on the mass of the object for it to accelerate. That is Newton's second law.
Okay, do people have questions either for the group or for me about Newton's second law? I'm warning you a little bit that it sounds like really simple at first, but it's actually kind of a complicated idea. So these guys will have to do a pretty good job of explaining it, because it's one of those where it seems like at first, like, that's a law. Why is that a law? It seems like it should be so obvious, but then when you really start thinking about it, it gets confusing. Okay? All right, so who wants to start? Okay, Clayton's going to start us off.
Should we do the
You do it.
So we're doing Newton's third law, and our title is Action is Reaction.
Our concept is when one object exerts the force on a second object, the second object exerts an equal but opposite force on the first.
Which means that if you hit something, the force comes back at you.
Just like our picture here.
Just like our example.
There's
Okay, so we drew a Karate Kid kicking a wall.
super kick.
The super and then it shows in the arrow, it shows the force going towards the wall, and then on the other arrow it shows the force coming back at him.
So you're saying that when the Super Karate Kid kicks the wall sort of pushes back on his kicking foot? Okay.
And so
Which
the kid,
forces the kid to say ouch. This guy says stupid, think about third law. Let's do math.
The math, reaction equals action, or the other way around. For there to be a stationary object, like if you put a pen on a desk, then the pen is pushing down with a certain. If you put a pen on a desk, then the pen is pushing down with a certain amount of force, and the table is pushing up with the same amount of force that matches it. And if the table pushed up with less force, then the pen would break through the table. And if it pushed up with a lot more force, then it would bend up.
Okay,
So now explaining the,
hang on to your questions and they'll answer them in just a second. Go ahead, Juan.
so then explaining the motion, there's this buff guy, he's roller skating. Yeah, he's six pack with his tight hair. And then where the skater is able to go because the wheels create very little friction, so the skater hardly has to push to overcome the friction.
So how does he get started? If his skates have very little friction.
Pushes on one leg.
If you push it,
Yeah.
But if I have very little friction, then it's going to be like when Fred Flintstone tries to start running in a car, he has very little friction.
I used to watch that.
So how did Mr. Little get started if he had very little friction? Oh, so Juan's saying maybe at the beginning of his motion, he had a lot of friction. Do you remember, I agree with you, do you remember what he had to do to get started?
Push.
So Jaden, I see you doing your feet like that, in that T. So you're saying that the T is what made him have a lot of friction at the start?
With just one foot.
With just that back foot, right? But then it sounds like Juan is saying that when he's rolling, he has very little friction, so he doesn't have to push too hard to keep himself going. Does that make sense?
Oh yeah, like if you're on a bicycle and you go really fast in the beginning, you don't have to do anything.
Because you built up some speed.
But eventually.
And then from the first law, what is that when you've built up some speed and you can just keep rolling?
Huh?
From the first law, what's the name of that thing? Inertia? Inertia? I know, you're learning a lot of new words. Okay, what else do you guys have to explain off your poster?
I have a question.
Other ideas.
Other ideas. Another idea of Newton's first law that when there is a pulling force, there is another force pulling in the other way, which is friction, which is kind of says that friction is pulling you back while you're trying.
Whenever you're pushing forward. Are you going to explain the words? Here, I'll hold it up.
Friction equals forces that push on objects negatively. And then FW stands for, the little W stands for force of gravitation. Force of gravity. And then the F with the little N right there is normal force.
That was funny.
Yeah, so we were.
Yeah, I actually wrote graffiti.
Like, does our shadows sound confusing to you guys?
Yes.
What?
Well, like we said, action is reaction because in the main package, it doesn't really matter which one is action and which one is reaction. You can switch it around if you want to, as long as one of them is reaction and the other one is like action. So like the Karate Kid can be action or reaction, but the opposite one has to be one of the two. That's why we said action is reaction.
So like your child is walking.
So like, if, here Clayton, put your hand up like this. So if me and him push against each other equally, you push against me equally. Like, it's, yeah, we're equal. Like, it doesn't matter, he's saying it doesn't matter if I'm action and he's reaction, or if he's action and I'm reaction, it doesn't matter. But if I let him push me harder, like, now we're not doing the third law anymore.
No.
Oh, because that's
Action is overpowering
action.
reaction.
Okay.
Okay. So wait. Before Amy begins to ask her question, I need everybody to listen because Amy's question might be really important for the rest of the audience.
Yes.
So
Okay.
I know you're very wiggly. Please try to stop wiggling. Okay, Amy's question.
Okay, in the other ideas you wrote Newton's first law, do you mean like Newton's third law?
Oh,
Where?
well, first law.
Sorry. It's the third. Actually, that's the new style. That's the new style now. First, second,
Hey,
third,
you should
third,
do your
third.
thing. Hey, think about the third law, not the first. Yeah.
Okay.
Okay, so it says negative 5n equals 5n equals object what?
Stationary.
Oh.
It's not moving.
Wait, can you
So that was like what Clayton and I just did. If I'm 5n, he's negative 5n.
So is it like
I mean, I get what it means.
equal force equal zero?
When they're equal, it'll stay the same. It won't move.
It's like what we did yesterday. So we just
Yeah, like.
So are you starting to see how the laws go together?
yeah.
Yeah.
Also, that
I can
just means
overpower
equal
her
force
and
plus
make
equal force equals zero.
Like for the example thing,
This one?
The Karate Kid guy?
yeah. So it means like for like this right here. So this is the wall. Like if he hits it,
You can't go busting.
yeah, he'll like back on.
Unless he has more force than the wall, which is really hard.
How do you know, man?
No, I picked the wall and it broke. It was
Yeah,
pretty
that's
funny.
more.
But this wall will not break.
Okay, you made it more action.
Your wall isn't made of sticks.
Okay, so he's asking questions.
Yeah.
If you hit something, the same force comes back at you, right?
Yeah. For example.
How about if you hit air?
Yeah, it'll come back. No, we're stronger than air. So we go. Yeah. Air doesn't have.
What if it was, have you guys ever like tried to walk outside when it's really, really windy? So it's like you can't, so you're saying like that if it's really super windy, you can't make any, you can't walk forward,
We can't walk that fast.
which is kind of like your parachute example in a way.
One time the wind was so strong, I fell. Like,
Yeah, I fell too.
Mary Poppins for 30 seconds.
I was 3 years old here.
All right, before I have you guys leave for the day, I want to go over what your homework assignment is. So if you want to read along with me, you can just look up at the screen or you can get your own copy out. Did you just hear something crash into the wall? Or
Yeah, that. I think it's accelerated backwards.
All right, so you can listen to me. I'm going to read the background information paragraph to you and talk a little bit about what I want you to include in your story. Okay, so you can follow along up there or you can look on your own copy. Okay, for your homework, I'm going to have you imagine two cars zooming towards each other like in the image shown above. As the two cars speed into the intersection, you can hear their brakes screeching, but neither car is able to avoid the crash. Suddenly, you hear the loud clash of metal crunching as the two cars collide. Think about Newton's laws of motion and write a paragraph describing the events of a car crash using Newton's ideas about force and motion. Like this, where one hit into the side of the other one. Yeah, I think a lot of people have probably seen or experienced crashes like this around here because we have so many
Well, I've
intersections.
seen one like this.
That's scary.
That was red light. I was like,
All right, so you can, instead of writing this like a science report, you can write it like a story of the car crash.
awesome.
Okay, so, but in your story, I want these science ideas. So in your paragraph, in your story, can I get your attention up here? Thank you. Okay, in your story, I want you to include the idea of inertia. So you can come right out and define it, or you can just use it as part of your story to show me that you understand what inertia is. Okay, I want you to include ideas about how the mass of the cars relate to their inertia when they are at rest and when they are in motion. Okay, so both of those ideas come from the first law, and then the mass idea comes from the first law and the second law, a little bit. Okay, the third idea is a description and maybe a diagram of all the forces that are acting on these two cars as they slam on the brakes while skidding into their crash. Okay, so an idea about all the different forces, that kind of comes from the second law and the third law. Hang on just a second. And then the last physics idea that I want you to include in your story is a description of the interacting forces, such as the equal and opposite forces that are happening in the car accident.